Welcome everybody to this session. This is the session on technologies and tools. You see the agenda for the next 90 minutes here still on the screen. And we start this session with a presentation from the BKG in Germany on implementing Inspire download services at BKG. Please, Dirk, go ahead.
Okay, thank you, Lars, for this introduction. A lot of presentations open. So, welcome everybody. My name is Dirk Thalheim. I'm working for the Federal Agency for Cartography and Geodesy, also known as the BKG. And today I want to share our experiences on implementing Inspire download service for harmonized data models. So before I start, let me give you a short introduction about the company or the organization I'm working for. The BKG, it's an technical, I'm not seeing my slides here. Habe ich gedrückt. Okay. Yeah, I'm back again. The BKG is a technical agency under the Federal Ministry of the Interior. We are a central service provider and competence center for the German government for topographic data, cartography and geodetic reference systems. We provide a service center of the federal government for geoinformation and geodesy, which is acting as a central contact point to the above mentioned topics and a central data provider for spatial reference data. So actually providing data we are responsible for, the data we are responsible for is all small scale data, starting at a scale 1 to 200,000 and smaller. But we also distribute the large-scale data of the federal states, the Länder, which are starting at a scale from 1 to 100,000 and larger. Looking at the products the BKG is responsible for, we are providing digital topographic maps as plain raster data, digital landscape models in different scales, Korean land cover, geographical names, administrative units in different scales, and digital elevation models in different scales. Actually, we have a law in Germany called Geodatenzugangsgesetz, which puts them all under an open data license. So they can be freely downloaded over our websites. Further, we reported the yellow marked products, DLM 250, Korean land cover, administrative units 1 to 250,000, geographic names, and digital elevation models to Inspire. So we have to fill the Inspire requirements for interoperability. As everyone, or most of you might know, so the next big milestone is actually to implement or provide harmonized data models for Annex 1 themes. So, of course, we had to do this for our products, so we started to identify which Annex theme is covered by our products. We came up with a roadmap shown here for the implementation stages of the Inspire download services. Yeah. Also note that there are upcoming products like the NUTS, which is a kind of statistical units product, where we also have to fulfill the requirements for interoperability. So let's look at the technical solution. For the services, we want to base our services on Decree. So what is Decree? It's an open source software for spatial data infrastructures, and it implements geospatial web service specifications of the OGC and Inspire network services. So why did we choose Decree is it implements WFS standards in all versions, and it's designed for rich data models from the bottom up. This is quite important when you want to implement the complex data models of Inspire. Also, its backend supports a flexible mapping of GML application schemes to relational models. This is Decree mapping. I will call it a Decree mapping configuration, which I will show or go deeper on detail later. Further, Decree implements the WMS standards 1.11 and 1.30. Which is quite nice when you also want to provide a view service based on the same data source. Further points were we already had good experiences when we in using Decree when we participated in the European Location Framework project. And finally, Decree fits in our infrastructure. We are very familiar with the system requirements, and due to its open source, we have no license cost and can easily scale the software, which is a requirement for our server software. So, looking at the data transformation, I have mentioned we have participated in the European Location Framework project. There we were responsible for transforming the Euro geographic contents, Euro regional map and Euro boundary map to an extended Inspire data model. So therefore we exported the data sources directly to GML in the desired application profile and re-imported those files with Decree to the underlying database. We have well-established processes which transforms our products to the Euro geographic content, so we wanted to reuse those workflows we already established. Unfortunately, GML proved as very inflexible and had several drawbacks, so we removed the intermediate step of exporting to GML and directly transforming with FME to the database Decree is using. So far to the technologies involved. The process of the whole transformation of one theme started with the scheme creation. This included the creation of database schemes as well as the configuration of the mapping for Decree. Therefore, Decree offers tools which automatically create the mapping and database schemes from application schemes. This was first integrated within the web interface. It was a wizard, kind of wizard. But unfortunately, the latest releases of Decree dropped this wizard. So we wrote our own tool based on the Decree libraries where we can create those files from command line. I've seen in the Decree project there are currently some developments which are going in the same direction. So there might be a command line tool next time. The output was auto-generated code, so we needed some post-processing for that because it was not quite perfect. So we put the Inspire Annex schemes in different database schemes for a better structure, and renamed tables and column names, and also dropped unused feature types and properties so that the database scheme becomes more comprehensible and compact. All the results we published on GitHub, this including the database schemes as well as the Decree workspace configuration. So everyone who is interested in or using the same approach might have a look at it. So when the scheme was ready, actually our data transformation team could start transforming and filling the database. Of course, this could lead to further adjustment within the scheme, so we had to do several iterations. After that, when the database was ready, we could actually set up our first service prototypes and start validation of the services and feature types. So at this time, we required a method to validate data and services. So the question was, does the service work? Is the data modeling correct? So we required at that early stage of development feedback to reduce the cost for fixing of errors. So what tools can we use there? Most online validators were not suited because they are mostly concentrating on the metadata and service parameter. So, and of course they can't be used for internal services that are just available in the internal network infrastructure. So our first approach was manually typing URLs, but this became quite soon annoying. So we implemented a simple command line tool which automatically tests all the provided web feature service feature types against the underlying scheme. This we published on GitHub too, so who has interest may have a look at it. So nothing is perfect right from the beginning, so we required several iterations to actually implement one Inspire Annex theme. So when everything was ready, we could actually start our publication. This included finalizing the service configuration, publishing metadata, and start external validation against the Inspire Online validators. So what did we achieve is actually we transformed all the Annex 1 data our products are covering. Especially looking at the DLM 250, we have the web service online because this service or this product includes four Annex 1 themes: transport networks, hydrography, administrative units, and protected sites. So our next steps are actually to finalizing the metadata records. This is not really finished. And start an external validation process. Of course, we have to validate and optimize the performance. This is just the first approach, and no further investigations were done on that. And yeah, last to name is that we have to transform and implement the services for our other products and Annex themes. So there's quite a lot of work to do. So yeah, so we've done it. We have implemented a service for Annex 1 themes. What can we actually do with it? It was quite an interesting question in preparation of this conference. So because there are no ready-to-use clients for Inspire WFS available, and most GIS have troubles handling complex feature types. Well, it's not impossible. You can use, for instance, QGIS with some extensions, but it's quite away from perfect. So looking at the data models in detail, for instance, transport networks, they are way too complex for simple use cases because they are using a very loose data structure where some attributes or categories are implemented in separate feature types, and the reference is only done via URLs. So filtering, for instance, on a subset of data or even visualization on category-based visualization becomes impossible. So let me summarize our experience so far. It is quite hard work to implement one Inspire themes. During that process, we learned a lot about the Inspire data models. Well, my opinion is in some cases they are not practical, but I guess most of you have heard that in other presentations too. And on the other hand, we learned a lot about Decree. It's a powerful tool to implement those services, but some IT skills are needed. Most of the configuration is done in XML files, so yeah, you have to be familiar with that. And unfortunately, I have to say the community is not very active. We had during our implementation phase some questions and posted it to the community, but didn't get an answer. So I would like to invite all Decree users to be more active in that community. So finally, we want to share. Of course, you can use our service because it's open data. And I've mentioned before, we shared our Decree configuration as well as the validation tool on GitHub. So feel free to look at it, comment it, and use it. So thanks for your attention. And yeah, if there are questions, please ask.
So we have time for questions. Are there questions, Dirk, on these implementation being straightforward? So I will start with the question, this one. You said you had issues with your metadata, or you did not yet create the metadata records. I always thought it's anyhow the other way around, that first there was a metadata and then there was a data set. But anyhow, why is that an issue? What is the issue?
Just we have to validate them. We just got finished with the services short before this conference, so we need to have a deep look if everything is fine.
Okay. Further questions? Hints to degree usage? Comments? That's not the case. Thank you again very much.
Okay, thanks.
So in best case, we move on to the next presentation. Next presentation is by Sonia Cekusic, hope. It's about implementing of national SDIs in the region of the Western Balkan, and hoping that technicalities can be solved. Perfect.
Yeah, thank you very much. Yes. My name is Sonia Cekusic, and I'm working in the State Geodetic Administration in Croatia. I will present you now the latest achievement within Impulse project. My presentation, I have to admit that at the beginning, it's not too technical, and I hope that you will not, because of that, find it too boring, or at least that you will find it partially interesting for you. So this is a project in which we are supporting the implementation of NSDIs in 6 countries in the region of Western Balkan. Beneficiary organizations are 8 institutions in that region, and those institutions are mostly in charge for cadastre, state survey, and SDI. When I'm saying Western Balkan region, then I mean on the 6 countries: Macedonia, Montenegro, Kosovo, Albania, Serbia, and Bosnia and Herzegovina, with 2 entities, Federation and Republic of Srpska. Project is implemented by Swedish Lantmäteriet and Croatian State Geodetic Administration as a junior partner. So this is a 4 years project, and we are now in the last year of the implementation of this project. So, as I said, we are supporting the implementation of 7 NSDIs, and we are doing it in a way to serve as a base for regional SDI, of course, all in compliance with INSPIRE. So, to be more precise, we are developing a national metadata catalogs that are accessible by all stakeholders. We are developing services for access to spatial data. Services are tested in the use cases, and I will talk about the use cases a little bit later. And we are working on harmonization of data, of course, in a compliance with INSPIRE, and we are supporting the establishment of data sharing mechanisms, such as agreements, laws, sub-laws, that will make it possible for users to actually access and use data from governmental organizations. So if we present our development of one SDI as a bumpy road, like this one in the picture, we can say that in the project we are somewhere in the middle. So with the yellow it is described. So we are working now with other stakeholders. By other, I mean other than the beneficiary organizations, so stakeholders within the countries, in developing of SDI components, metadata, to do the metadata, to harmonize the data, and to develop the services, and to, of course, start sharing their data. At the beginning of the project, we have developed those components within beneficiary organizations. Then we gradually started to introduce the other stakeholders. So what is the methodology in the project? This is twinning-like project. That means that 90% of the work is done within the beneficiary organization by themselves. And experts are supporting them in a way that a lot of national workshops, a lot of regional workshops are organized, and we had online training, and also we having individual consultancy when it is needed. So in a way, we dare to say that this is a unique project, because in a parallel we are developing 7 NSDIs in the same way, and we hope that this will, by doing that, we will achieve a shared regional SDI. So I will now shortly introduce you to the achievements and future activities of the projects. So we have 4 NSDI laws in force, 3 are drafted. We will continue to work in that field in supporting the adoptions of the law and developing complementary bylaws and guidelines. 6 beneficiary organizations are nominated as national coordinators, and they have functional structure for coordination. So we will continue to proactively work on the coordinating tasks. Regarding metadata, regional metadata profile is developed, of course, INSPIRE compliant, and national metadata catalogs are developed according to the regional one. Those metadata catalogs can be harvested by other catalogs. Metadata are produced for 4 datasets and services, so we have started with first 4 datasets: administrative units, geographical names, elevation, and orthophoto. Those metadata are produced according to the regional profile, and some beneficiary organizations have started to develop metadata for other products, and this is what we will do also further on, to develop metadata for the products of the beneficiary organizations and for the products of other stakeholders. Regarding harmonization within project, knowledge is increased in that field. Data for those first 4 data sets are harmonized using HAIL and FME in all beneficiary organizations, and now we are working further with the harmonization of other data sets, and we are supporting stakeholders to do the same. Similar situation is with developing of view and download services. So knowledge is increased, services are developed for those first 4 data sets, and we are working further in that field. The main point is that we make all our services INSPIRE compliant, and to continue to support stakeholders in the service development. At the beginning of the project, a data sharing agreement between beneficiary organizations for pilot was signed, and we are now working more on the establishment of national data sharing mechanisms. Regarding monitoring, some beneficiary organizations have created lists of data custodians and responsibilities, and now we are working more in that field to start the monitoring the development of NSDI in the respective countries. So dealing with so many beneficiary organizations and so many countries, we have to admit that we had a lot of project challenges, but also we gained a lot of big and positive project impacts. Project challenges are coming mostly because of the sometimes big differences between countries and beneficiary organizations, like political support and organizational structures are normally not the same in all countries and in all beneficiary organizations. All organizations are having their own internal problems, challenges, and priorities. Experience and knowledge is not the same, was not at the same level. Status of digitalization of spatial data among stakeholders are different in the countries, as well as status of development of geoportals. So at the end, maybe also very important difference was the expectations from the public and interest in, and support from the stakeholders. But as I said, we gained a very good positive impact, like which I already mentioned. We are simultaneously developing 7 NSDIs and make prerequisite for the regional one. We are jointly fulfill the project results and exchange our knowledge and experience, and working together in the project, communication between beneficiary organizations and stakeholders in the region is improved. So to show the benefits of NSDI and to test the feasibility of accessing harmonized data through services between beneficiary organizations, we have developed use case. So with this use case, we have confirmed that there are metadata available for selected data sets and services for cross-border purposes, that metadata are made according to the regional profile, metadata catalogs can be harvested from beneficiary organization, and data can be viewed by the use of the view services. At the beginning of the project, we have identified data set for the use case in a lot of discussions, in a lot of meetings, and we have decided to start first with those four data sets which I already mentioned for a risk management purpose. Then we will continue with the second phase of the use case, working on transport data, hydrography data, and statistical data. So, as I said, the status of implementation of geoportals at the beginning of the project was very different. All beneficiary organizations worked a lot on that field. All geoportals are now improved and all have a catalog web service. And because I don't have much time, I will just quickly show you how does it look like this use case with these two data sets, administrative units and orthophoto. And we are hoping that by the end of the project, we will really gain our goal, and that is to have harmonized data for all, at least all 7 data sets and additional data sets if possible, and to develop services for them. Thank you very much for your attention.
This was very quick, thank you. We have plenty of time for questions and comments. So please, your questions. All in the lunch corner. Yeah, please.
Yes, please. I have some question, maybe one comments. first presentation was excellent. Thank you, Sonia. But I have to say that this project is very, very important for us in the region, for all regional agencies in Western Balkan region, but especially in the NSDI sector. Thanks to the project, we strengthened the awareness of the importance of the NSDI sector, implementation of an Spatial Directive, etc., etc. But on the end, I have to say thank you for our Swedish friends, colleagues of Sweden and Swedish government, SIDA, for understanding and helping.
Okay, thank you. Are there further questions, remarks, comments? And I would like, oh sorry, go ahead. Short question.
So you mentioned that you used two ETL tools for the data harmonization part, FME and HAIL. Why you are using two ETL tools?
FME was used by some organization, I don't remember which one, before, and that is why they keep working in the FME. And HAIL was introduced actually by Swedish experts, if I remember it very well. Yeah. And the rest of beneficiary organization find it very, very useful, and they were satisfied with this one.
So do you prefer one of them?
As I said, different organizations are working with different. Because some of them already had some licenses for the FME. That is why they keep to work on the FME. The others started to work on HAIL.
Okay, very diplomatic answer, Mrs. Fine. A question towards the costs. You said that the rough budget was about 4 million,
yeah.
If I got that rightly. But I guess that was a project of the project, the budget of the whole EU project.
Not EU, it is SIDA funded project. Yes, I'm sorry I didn't mention that at the beginning.
I guess you did, but I was wrong.
Yeah.
The question is more, I mean, if that was the budget of the project, have you an idea of what was the additional budget that was put in by in-kind contributions and so forth? So what were the overall costs of these developments?
We didn't start to investigate that field, but by the end of the project, in our final report, I'm sure that we will have to handle with that topic also. But so far, we did not did that calculations.
And related to that, of course, the question: do you plan any kind of benefits calculation so that you?
Absolutely, absolutely.
Interesting to see it. Thank you. Okay, there seem not to be more questions, or are there any? Still have? Sonia was so perfect in keeping her time so that she would deserve more questions, of course, and comments. Yeah, the final one.
My name is Betta Westrom and I'm from Lantmäteriet. This project has been quite big and it's not always so easy to work with so many, but everyone has made a lot of efforts in this project, and it's not only we who give the beneficiary organizations knowledge and so on. We from Sweden and Lantmäteriet has learned a lot within this project, so we also have benefits. And it would be interesting, I think also that Croatia has had a lot of benefits in this.
Absolutely.
But I think that the questions that you have are very important, so we will try to calculate and see the benefits, how much money can we save by doing this. Thank you.
Thank you, Peter. Thank you again.
Thank you.
Thank you. And we move on with another presentation, which I guess is a bit less on the technical level, if I got the title rightly.
That's true, yeah.
It is about evolving SDIs and SDI governance from Jaap Willem from the University of Wageningen.
Yeah.
And the floor is yours.
Yeah, well, thank you. Yes, first of all, I also have to apologize that it's not a technical or tools session, but I think it will add nicely in the previous presentation. I'm Jaap Willem Sjoukema. I'm a PhD candidate at the Wageningen University and also supervised also by the KU Leuven in Belgium. And I also work part-time at the Dutch cadastre, so I have both the theory and the practice I try to combine. And I have the nice PhD subject to evaluate the governance of SDIs, of spatial data infrastructures. And when we talk about spatial data infrastructures in the Netherlands, we like to make a comparison with the physical infrastructure, like the highways, for example. And then we show an old picture, and then we show a newer picture. And then we say, just like railroads, also SDIs need updates and maintenance to improve. But we never show this picture, and this is from my hometown in Utrecht, in the central of the Netherlands. And what you can see on this picture is a nice canal. But in the 1970s, they thought, well, canals are a bit like the medieval times. We need more highways. And so they built a really nice highway, and nowadays it's a canal again. So what I try to show with these pictures is that decisions are not always straightforward. And this is the physical infrastructure, but the technological infrastructure will change much more often. So we need governance on that. And the first question about governance is, what is it exactly? There are so many definitions that nobody actually knows what governance is. The nice thing is that you can make up your own definition then. And what I extinguished from the literature there are three key ingredients in governance. On the one hand, that are the actors and the stakeholders, so people and organizations. On the other hand, you had the institutions and the structures, just like the laws and rules, but also the informal laws and rules, just like culture and behavior. And between them, there is also interaction. So you have hierarchical interaction, just like you have to follow the law. There's network interaction. I think this is one where we all hear. It's one big network interaction. And next to it, there's also some market and self-steering behavior between all actors. And as I like to simplify, I also say this: we have the players, we have the game rules, and we have also the game mechanism. And what governance is actually the total gameplay. And it's not about who wins or who loses, but it's more about the process to come to those results. So why is SDI governance important? Well, governance is the driving process in the development and management of SDIs. It delivers the decision. Before we can have awesome technology and tools, someone has to make a decision that we will go for it. But what you can see in many SDIs, in many cases, is that they are project-based developed without any structural financing and governance. They are very complex with a lot of data, but also a lot of stakeholders. And they are also growing. Thanks to, for example, open data, there are more stakeholders than before. And they are also constantly challenged by new technologies and user demands. We talk about spatial data infrastructure, but we also want smart cities and big data and linked data and stuff like that. And there is also a problem that they are not very sexy. They lack a political awareness, in most situations. So how can we tackle such a complex subject? Well, there is in the past there was a very wise guy who said, "Study the past if you will define the future." So that's what I did. I took two cases in the Netherlands and in Flanders in Belgium, and which are not inspired data sets, but are about large-scale topography, so very zoomed-in maps. And try to reconstruct the governance development based on industry magazines, geoinformation industry magazines, and try to identify the key transition moments in which there are important things going on. And the nice thing about these cases is that they are quite similar. I will not explain all details, but when you have the large-scale base map of the Netherlands, which is called the BGT, of de basisregistratie grootschalige topografie, it is a countrywide map of the Netherlands with a very high level of detail. It's keeping up to date, standardized, with object-oriented, so you can use it in your GIS. It's open data. And also very important, it is an authentic registry, which means that it is mandatory by governments to keep it up to date and to keep it of good quality. But also there's a mandatory use of the map, and there is also mandatory feedback if the map isn't what you thought it should be. That's all written in the BGT law, and well, just like I said, it's all open data. And when you go to the GRB, the large-scale base map of Flanders, or the Dutch name is grootschalige referentiebestand, then you can make a kind of similar picture. It's also a country of region-wide coverage, I have to say, with a high level of detail, even a bit better. The up-to-dateness is a bit less, but also nice enough. It's also standardized, and you can download it in many formats, even CAT and 3D data. And also it's an authentic registry with mandatory use and maintenance and stuff like that. And written in a degree, the GRB degree, and also disseminated as open data. But there are also very much differences between those products. For example, the BGT is created by 430 different governmental organizations in the Netherlands, so it's locally created and then disseminated centrally, while the GRB is centrally created and disseminated. Also the financing is very different, so the BGT is paid by only governments, but the GRB is also an important actor in it. Are utility companies which are using the map for referencing their cables and pipelines. Well, you can also see that in, for example, the steering committees, that the BGT has also a lot of broader steering committee with data providers such as the municipalities and users, also utility companies, but also the central government, where the steering committee of the GRB is more focused only on the utility companies because they pay the bill largely. What is really interesting is that the BGT, you can trace it back to 1971, so even before there were really spatial data, but were more maps. And there was already an initiative to create together a large-scale base map of the Netherlands, analog-based. And in 1975 there was also an official decree declared to make such a map. However, it didn't really work. Around 1992 only 10% of the country was covered. So the government has to take an intervention and said, well, we quit with it. There was also a pressure on the cadastre to privatize and to recover their own cost. And they actually said, it was a nice experience, but we quit now. And municipalities and utility companies, you have to find your own way in creating such a map. But so they also scrapped the legal status of that map. But instead that the production failed and they stopped. They become more creative, and they created some public-private partnerships together, and they really were ambitious to create a large-scale base map within 10 years, and they succeeded. So in 2002 there was a nationwide coverage of that map. In 2008, the central government came in the picture again and thought, well, that's a nice map. And there was also a large lobby of that previous BGT map to come more officially. And they created the BGT program, and they transformed actually their own the old maps, which were partly analog and especially more of the lines. Instead of objects, to create an object-oriented map, and nowadays we are almost completed with the map in 2017. The development trajectory of the GRB is very different, which is also two origins. And it started actually as a private initiative. So the company thought, a large-scale base map, that's nice, I can sell it and I can create it. But actually, they need to find partners because it's a very expensive undertaking to create such a high detailed map. And they weren't really successful in searching all those partners. And when they, 9 years later, they got bankrupt. But then there was a GIS Flanders initiative, what already started earlier to make GI more professional within Flanders. And they took actually a bit the over and initiated the GRB. In 2004, it got official, and they also got an official organization in 2007, which already is gone and gone up in a more as it was really a GI organization, and now it's more moved to an e-government organization. And within 10 years, they also completed the GRB in 2013, and also gained open data. So what we can learn from those long trajectories of creating such a large-scale base map is interesting is that they both emerge from network activity, so a community which is really wanted to have such a map and searching for opportunities. What's also interesting that they had a slow and almost failed start with the predecessor of the BGT, almost failed in gaining some speed, and also in the GRB predecessor, which got bankrupt. But after that movement, it really sparked self-organization and governance improvements to create such a map within 10 years. Both initiatives also accumulated during their course a broader mix of market type mechanism, also network type mechanism, but also hierarchy, which is also showed in the next picture, which is I thought quite interesting. So what you can see is, for example, the BGT, the blue line, at a very hierarchical approach at the beginning, but it broke down the way. And at the end, it got much more hierarchical instruments when it became the BGT. And in Flanders, you can see a much more organic growth of their hierarchical instruments. But there are a lot of governance. People were saying, hierarchy is a bit old school, and network is the new thing. But it's more both. So there is both network steering, but also hierarchical steering. What we also can see in the actors is that they are constantly reshuffling their positions. So sometimes they had to pay, sometimes they didn't have to pay, and just recently there is a new reshuffling busy. What you can see is that especially the national, but also the local governments gained a more important role. So the interesting thing is, of course, what can inspire learn from these evolution of those two cases. Well, first, what we can see, it took around 20 to 25 years from the first nice idea to the successful implementation of those large-scale map. So when we reach 2020, it's quite soon, and then everything is happy and living further on. Next to it, there is not such a thing as survival of the fittest, so you don't make 10 SDIs and see which one survives. But what you can see is that when an SDI is going to fail, there is actually a kind of boost to improve, and which also improves the productivity. So it kind of works, but of course the drawback is that it costs a lot of time and tax money, so we want to avoid it still. What you also can see is that the governance changed a lot during those courses, and that it perhaps also should change a lot to still fit the needs of the SDI community. What's also very important is that even legal requirements are not holy, so they can also, when everyone wants to get rid of the Inspire directive, we can, but I won't recommend it. But you should know it's not that holy. And also the self-organizing abilities are perhaps even more important. So as what you see at the BGT case, there were no legal requirements anymore, but the community wanted to move on, so they created also a new map, which they did much faster than before. And next to this, like I said before, it's important to mix up different elements of network market and higher cost steering. Just not focusing on one, but mix them so you become more adaptive to change. Well, thanks a lot for your attention, and if you want to read more, I published also an article about it, and you can also reach me on email.
Thank you. I'm still wondering whether we are at the stage of failure or close 5 to 10 years close to the success of Inspire, so that is now for you to think about. Are there questions to this presentation?
Thank you. The presentation was really interesting, and I really like the topic. I have a specific question. Did you find any evidence in your research that the Flemish case has influenced the Netherlands or vice versa?
Yeah, they did learn from each other. So there was also like an ambition, for example, with the predecessor of the GRB to be quicker than the Dutch, for example. So you can really read it back. So they learned from each other, and also yeah.
So you will also study the Wallonian case?
Yeah, which is also interesting, of course. Yes. So I just at the start of my PhD, so a lot to study.
So you can get the ideas here. Are there more comments or questions towards the presentation? Okay, interesting stuff. Thank you very much.
Thank you.
And we move on. I think we get a bit more technical now again in this and the next presentation. And this presentation is on the water switch on spatial information platform. It's by John Zala from Deltares. And I hope you'll find your presentation.
Yep, me too. Yep, there we go. Yep, the following presentation is yet another SDI presentation. It is actually a SDI that could be defined as open data in the field of hydrology within a European project, and that is the case of the water switch on project. We call it the Spatial Information Platform, and is a set of tools. It has been developed by Deltares and Kismet. Deltares is a water management research institute in the Netherlands, and Kismet is a software engineering company in Germany. Moving on to the presentation contents. We'll start first with some context, and then we'll move on to what ideas we had at the beginning of the project, what were the requirements. Then we will present the technical solution and all the components, and then we'll talk about documentation, code, and finalize with some conclusions. Switch On is a water information platform, and it's about open data in the field of hydrology. We allow users to upload data, download data, so Inspire services, and we also comply with ISO, so we have Inspire metadata too. We are building bridges between policymakers, water management, and at the end the scientists, which are the main users of the platform. It has been going on for already quite some time, and it's finalizing now. So since 2013 and finalizing next month. So we are already, let's say, in production. It has been done by a group of heterogeneous partners, such as universities, governmental institutes, and small companies. And yes, it's within the 7th framework of the European Commission. Moving on to the requirements or design principles. Well, in the blue box we see an example of a use case. The use cases were defined by scientists from the universities, and we as developers had to think of features or characteristics the system should have. And those can be summarized in, well, not all of them, but some key points. We need spatial search, but not only a bounding box search. we find it very useful to have polygons to search water-related data sets such as lakes, rivers. So we had that requirement. Also, even if it's open data, we need the license-based search and different types of open data licenses. We use inspired topic categories to define our datasets, and also American quasi keywords. That is an hydrology ontology. Yeah, the system should be open. That means we reduce all the burdens and we let users to upload data without even registering. We want the system really to be used. Also, we have a moderation system. We have people behind that approve and complete the metadata in cases that there are not enough. And we don't intend to be the catalog for water information datasets, but rather be able to be harvestable by bigger entities such as GEOS, the group of Earth observations, or even the Inspire GeoPortal. Yeah, how did we proceed to develop such platform? Well, first we made a failure. We started the developers developing something that the scientists didn't like. So we went back to the drawing board and we did table discussion with the scientists, and we wrote use cases that led to better interfaces, better graphical user interfaces. Yeah, those stories were written in GitHub issues. One more approach we followed is the divide and conquer approach. Yeah, we developed our system not only in one software component, but rather a constellation of components that communicate via REST services, most of them OGC protocols. And we use ISO standards as well for standardizing the metadata. We have there's 3 layers: data, service, and GUI. Moving on to architecture. These are the global architecture. We see all the components. The ones in red are the ones we developed from scratch. That is the discovery service named Browse Your Open Dataset, as well as the upload service, the metadata wizard. Those are the main components we developed. We also took open source components, very known like Threads or GeoServer, to provide access to the data. We didn't want to implement that ourselves, and because they are very good software solutions. And we recycled some of the components of Kismet in order to, they ended up in a zip expert tool to moderate the data. This is an overview of all the components and which technologies did we use. As you see, technologies, it's perhaps also relevant that they are all open source technologies. We use PI CSW for catalog, for instance, Python implementation. And on the left side, you see the functionalities. So search, view, download, discovery. Those are, all the functionalities we provide to the users. We're going to go one by one. First one is the Browse Your Open Dataset tool. It's the visible face of the spatial information platform, and it allows users to search directly on a map with the spatial preview, and they can also filter by keywords, predefined ones like inspired topic categories, or even they have a free text search, because sometimes you want to just, it's the Google approach, I want to search my own query. And apart from the map view, we have a list view. That is, so you can switch from one to another on the top left button. I find it quite interesting, because that view gives you a more very good overview of your search matches. And you have columns. You can see the keywords per data set that you found. You can also filter by data origin, the licensing options, and see what data accesses provide. If you click on one row, you're directed to the metadata page of the given dataset. Of course, we need a tool to let the users upload the data, because this is an open data sharing platform. We don't intend to fill the system ourselves, but rather user inputs, scientists all over Europe. We do that in a 5-step wizard approach. First, of course, upload the files. That can be in a zip file or multiple files. And and then a second step that we provide some basic description of the dataset as an abstract and a dataset name, of course, some keywords, inspired topic categories. And on top of that, we allow the user to create a digital object identifier that I will explain here. We do that through the Zenodo API. It's also a REST API from an external project that allows 50 giga per dataset. It's quite huge. And the thing is that leads to a digital object identifier that the users can use to citate their data in the publications, and I find it really useful because then you can always have reproducibility and also citability. The following steps, we need to define a geographical location for the dataset we are uploading. That you can do by clicking a country if it's a national dataset, or if you want to provide a better, you can provide a bounding box by input coordinates, or even if you know it's a lake or some particular dataset, you can draw a polygon within the map interface. Final step is the licensing and the point of contact options, and that's mainly it. Once you have this, you can upload the dataset and show it then later in the BIOT tool. Of course, since it's an open process, you need some moderation, and that is done by the Swedish Meteorological Institute in Stockholm. And they have this tool called the SIP Expert tool that allows them to manage the datasets. Let's say they can even delete metadata if it's not good, or a dataset that is not there anymore. They can extend metadata, and they can, basically it has also GIS capabilities, so they can view. On the data layer, we have a relational database model stored in PostGIS, and from there we provide the CSW service. We can map all the fields to the CSW and make it harvestable by other entities. Just to say that the data is stored in GeoServer threads depending on their type. That means, for instance, an HCDF file will be stored in threads, so it provides OpenDAP and other services, and GeoServer will store, for instance, shapefiles and as layers. We are also, from now on, a Geos data provider, and that means that we are in the geoportal.org, and switch-on datasets are also searchable by a bigger entity that provides remote sensing. It is the biggest portal you can find in this field. How do we do this? They harvest periodically our CSW service, and moving on, documentation and code. We tried to follow a different approach for this. Instead of boring documents that nobody reads, we have a YouTube channel where developers and scientists, we show how the tools are used. And I think it's a very nice approach. And yes, of course, it's about open data, but also open code. So all the code we created is findable in the GitHub project of Switch-on project. Sorry. Also, we use the GitHub issues to iterate on the agile process of developing the tool. Moving on, conclusions finally, and the Switch-on architecture is OGC compliant, several components, and the agile development was successful. We learned a very good value and lesson there. We use inspired topic categories to define our data alongside an extended quasi-American ontology for hydrology. We also use the Zenodo REST API to provide digital object identifiers for the data, so the work is citable and findable, and that the users love, especially. And thanks to the CSW protocol, we are harvestable by bigger entities, such as the GEOS system of systems or the Inspire Geo portal. And yeah, all the code we produced is open source, and you can reuse it. And yeah, there is documentation online available on the Switchon YouTube channel. Yeah, and that's mainly it. Thank you. You can check the website, is waterswitchon.eu.
Okay. Thank you, John. And again, we have time for questions. Please.
Thank you for this presentation. I have a question. It's about metadata wizard.
Mm-hmm.
Can you tell us more about this part?
Well, the metadata wizard is coupled with the upload process. So you upload the dataset, that could be a shapefile or a raster. And after that, you have some steps to define the basic profile metadata. So after that step is, well, those steps are completed, you push the data to the server, and that data is available on the Bayat tool. So users can search it and download it.
Okay, it's not something to help the user to write metadata, give advices, or something like this?
No, it's more a tool to complete the metadata, okay. And then, well, if there is further completion needed, SMHI will do it with the other tool that is more complete. But we didn't want to put like a very complex metadata describe process at the beginning, because when the users see a form that is like this, they run away. Mm-hmm. So we did it in several steps, like a wizard, and next, and then, yeah, I think it's a good idea to keep it simple.
Okay, thank you.
Other questions? Otherwise, okay.
So what is the geographical coverage? Is it only Europe, or
it's mostly European?
If so, do you have plans to extend it more globally?
Well, that is one of the reasons we use the quasi-American ontology, because we are in contact with people from the US too, so they can use it too if they want, although they have similar projects in the US. So yeah, I would say the aim is more European, since it's a European project.
I would have one question related to the DOI, the Digital Object Identifier, that had been invented initially to identify peer-reviewed journal papers, and then was more and more used also for research data.
Mm-hmm.
Having said that, what is your reviewing policy for the data that is uploaded? Or is it just uploaded and you hand out a DOI for that?
For the moment, we just generate, and yeah, we trust the user in a way, yeah. But yeah, there is the moderation process behind that after. Okay. But in order to make, to encourage users to use it, we made it really straightforward.
Yeah, I would recommend to rethink that process, because there's a way of in that way contradicting to the initial idea of the DOI, right?
Okay.
But that is not only your project, there are several projects about that one.
Yeah.
Yeah. Okay. So if there are no further questions, we are perfect in time, so there would be space. But then we move on to the final presentation. I see you're heading for coffee. But before you leave, we have the ultimate presentation of that session. That is by Michael Vogtländer from ESRI Germany. And he's talking about...
Sorry, the actual names.
It's only one name in my program, but obviously you're not Michael. Sorry for that. So you do your introduction, and you are talking about Inspire Shared Service Operation.
Okay.
Sorry.
I'm not I have to drink something first.
Stop.
Yeah. Okay. That's okay. So, thank you very much for the introduction, Mr. Bernhard. Good afternoon, ladies and gentlemen. Nice to meet you in our presentation of the Inspire Shared Service. My name is Petra Fritz. I'm geographer and project manager. And I'm working at the HZD, the Hessian Center of Data Processing in Wiesbaden. May I ask you, who knows Wiesbaden? There are some. I didn't expect this. And who knows Frankfurt? There are more. So Wiesbaden is situated very close to Frankfurt, and Wiesbaden is the capital of Hesse, the state of Hesse, and the location of many authorities. Together with Mr. Vogtländer, GIS account manager from S3 Germany, we want you to show how Inspire can work from the technical and the operational and the organizational point of view in an easily and comfortable way. As it is established in the HZD since 3 years and open for all who are interested. The HZD is the Hessian Center of Data Processing in Wiesbaden, and I now use the shortcut HZD. So, the agenda. First, let me present a brief glimpse at my company, the HZD. And the following, we give you an idea how the Inspire Shared Service, I now use a shortcut ISS because it's a long word, Inspire Shared Service, now we call it ISS, works from the organizational and the technical point of view. What the current projects are, is this too loud when I speak so close to them? No, it's okay? Okay. And at last, what the current project and the future aims of the ISS are. Right now, the HZD is more than 45 years a reliable partner of the Hessian State Administration and other IT corporations. In 2017, we are around 800 people in the staff bundling IT know-how. The HZD stands for Innovative, High Quality and Competitive IT System Development and Operation, e.g. Data Center, Hessen PC, IT Fabric, Hessian Wide Network, and the very important topic now is IT security. And the HZD strength is a professional, quality-assured IT service from one source. And so, from one source, this is a bridge to our topic today, creation and operation out of the box. The HZD also operates as a provider for geodata infrastructure in Hesse and ensures customer operational and support-orientated solutions around the topic of geoinformation. That's about the HZD. Now we come to the implementing of the Inspire Shared Service. Together with the Center of Excellence for Geoinformation at the Hessian State, we started a project in 2014 and developed the idea how we can support the spatial data authorities to fulfill their legal requirements for Inspire. The Inspire implementation works as follows. The data creation and provision, including the metadata, is a part of the data creators and providers. And here in the middle, the HZD focus includes the data storage, the file organization, the service delivery as view and download services. And if it's desired, we do also transformation in the Inspire data model. So we focus on these technical operational part in the middle. When the services are released and the interoperable use is given, the authorities or customers make the registration by themselves in several geoportals, and the monitoring for the European Commission can be done. So the advantages or synergy effects of the ISS are obvious. the customers uses centralized IT technology and GIS know-how, and avoid own investments in all these parts. You use all advantages of a modern data center, secure data storage, and you avoid transferring your data in possibly unsecure data clouds. High availability is therefore self-evident. You all know this 99% availability, it's on the hand. And the ISS secures a high-level service for the customer. We manage the operation with a unified annual basic package for the use of the ISS, including the costs for all service we need, the data storage or licenses, including the GIS licenses, the updates, the monitoring part, and the monitoring part about the IT infrastructure, and a ticket system for error messages, and much more. So how can you use the ISS? Here's an abbreviated instruction in 5 steps. First, you contact us. You can do this per email, or you can call us. Second, you describe your issue, e.g. in which format you send us the data, what is the data volume, or whether your data is already transformed into the Inspire data model or not. Then we make an assignment based on a simple pricing concept. So there's a package for the operation of a service. This includes a flat rate, no matter what kind of Inspire theme is presented. And B, for the initial creation of a service. This means the pricing, all this must be individual, because it depends on the complexity and the quality of the data. And if the data is Inspire harmonized by the data authorities or not. Oh, sorry, I was too fast. Then the implementation is carried out on a separated test platform in tight consultation with the customer. So you look at the test platform if everything's all right, and when you give us a sign that everything's all right, we put it on the production platform. The services, then the implementation is carried out on a separated production platform where you have the possibility by default to update your geodata fully twice a year, or if you want more, you can update then more. And the package is included and fully update twice a year. Oh, sorry, I'm too fast. So now I give you the floor to Mr. Vogtländer. He completes the presentation with how the ISS works, the technical part.
Okay, thank you, Mrs. Fritz, for the introduction and introducing me. So, as you've heard, I'm from Esri, so if you have any question after this presentation, don't hesitate to come to our booth. It's in the conference area, it's a large booth, and if you have any questions, we can talk about this solution and for sure other solutions from Esri. So I will start, we'll go on with the technical part of our presentation. So in the Inspire shared service solution is based on, I start with the first step. So the first step is the spatial data authorities have to deliver the data in a harmonized or non-harmonized way. There are 2 possibilities. And then, based on these data deliveries from federal customers and maybe also cities in Hessian, which also can use this offering from the HZD, is the central ISS platform. We call it platform because it's made for many users, and from the infrastructure part, it can be scaled up to for an offering for many customers. And what's about the what the HSD platform consists. So it's on the first step the IT operation and also the infrastructure. Then the HSD has also a special data expertise, not only for Inspire and also for other data types and data standards. Then the offering also includes server, virtual server, and database resources, and special geodatabase which implements the Inspire application schema. Then for sure the network services, view service and download services which are provided in this infrastructure, and also the meta management is covered in this solution. Optional, there's an offering for harmonize the original data from the customer. Yeah, and then the goal is providing access via standardized services based on the Inspire network services. Let's go in the detail. So as you've heard, so I'm from Esri, so the main part of the solution is based on the Esri solution ArcGIS for Inspire. But the first step is the harmonization part, and the harmonization part is based on FME technology, and especially the extension for Inspire task, the Inspire solution pack for FME. These are the two technology stacks which are introduced in the HSD over the last couple of years, and it covers all central processes to deliver Inspire conform services and data. So the first one could be as an optional part for the customers. It's the data harmonization part. Then the ArcGIS for Inspire infrastructure. It consists of the database parts of storing the data in a predefined way to be compliant with the Inspire application schema. Then functionality which provides you server capabilities for publishing view service and download services. And then the last one is it's actually not a part of the solution of the product ArcGIS for Inspire, but it's part of the solution, the ISS solution. There are possibilities to reference existing metadata, which is created in an external geoportal. And in this solution, you are able to reference this existing metadata in your services based on ArcGIS for Inspire. So as I already have said, the first part is the data harmonization part, and it's based on FME technology. Why they're using FME? Because FME is kind of a standard for ETL tasks, extract, transform, load, and the Inspire solution pack extends FME with specific information and functionality to make the data harmonization process much easier. How does it work? So on the left side you have the original data model, and on the right side you have the Inspire data scheme, and the Inspire solution pack is a kind of a bridge between both worlds. So it delivers predefined templates which are covering all the annex themes. So at the end of this harmonization process, you are able to provide GML on the one hand, and for sure also a format which allows to store the data in the Esri geodatabase. Let's have a look on the product ArcGIS for Inspire, on which components it's based. So the first important component is an add-in, which is installed in ArcGIS, ArcMap, and ArcCatalog, and provides you the possibility to create MXD files and define your own style in your maps. So it's a kind of map authoring tool in ArcMap, based on the Inspire standards, for example, the default style for view services. But you also can define your own custom style for view services. Then I think the most important part is the geodatabase, which implements the application schema for the Inspire Annex themes. It's based on the SDE, which is a central part of the relational geodatabase, enterprise geodatabase from Esri. And the third one, which is the ArcGIS server extension, providing the capabilities to publish view and download service. So this, in the red box, is a central part of the main part of the solution, ArcGIS for Inspire. There's another one. It's called a GeoPortal, which provides the capabilities for metadata management and create a CSW, but it's not implemented in the ISS. Yeah, for sure, you have the possibility, and it's already accomplished, that you can use the download and view service in various GeoPortals, apps, and viewers, which are already provided in the SDI in Hessian. So there are three implementation options for the solution, which gives the HSD and also the customer in the back huge flexibility of the implementation options. The first one is, we call it as-is mode. It's for the customers which are not finished their harmonization process of their data. So you can pick your original data and publish it via compliant Inspire view and download service. So it's loading the data in the geodatabase, click publish, and then you have your Inspire view and download services. For sure, you have to add the metadata to the service and so on. Another option is to create different output formats, for example, file geodatabase, shapefile, but for sure also the GML. If you already have harmonized your data with the output format GML, you can reference this different data types in the atom feed and publish it with ArcGIS for Inspire. And the third most complex one is publishing the data via WFS services. So it's based on the geodatabase templates, which I mentioned before. So it's kind of an extension of the enterprise geodatabase, which implements the application schema. Then the data is harmonized, the data is stored harmonized, and on this database, the data can be published harmonized via view and download services. So there are three options, and it makes it very flexible for the customers, which way he wants to implement ArcGIS for Inspire services. And to summarize all these technical parts we have seen, we can see that we have all steps which are defined in the technical guidelines from Inspire. It's covered the metadata based on the ISO standards. We have a discovery service solution in the ISS. We have the data model implementation, and we have view service, different options for publishing view services, WMS and also WMTS. And for sure also the download service based on the WFS, and the other option, publishing an atom file, which is not implemented at the moment. And we have also for sure the service level agreements from the data center HSD. So I would like to hand over to Mrs. Fritz for giving us an overview about the current projects.
Thank you very much, Michael. Now I'd like to finish our session with an overview of what comes next and what we have done now, what is in operation. So the ISS is in operation. It is successfully tested and will be developed further. First services are in operation since 2015, like the services from the Hessian State Office for Regional Planning or the Hessian State Office for the Preservation of Monuments. All these protected sites with cultural monuments and natural monuments and so on. Then we have Hessen Mobile. This is a road and traffic management with the transport networks. And the Hessian State Office for Land Management and Geoinformation with all the cadastral parcels, e.g. In German are ALKIS, Basis DLM and DLM 50 and more. Not all of these services are now harmonized, but we have to do this job. I think the time is running. I think it's in the next January or February they all have to be harmonized. But the rule is the customers first want to make an operation with their original data model. So the first step is we put the services in their original data model into the internet. And then we have time to make the harmonization, and it's up to the customer when he wants to do this. But some customers also like to have both the services in the original standard and in the harmonized standard. So because they use both. Some more for their daily work and some for Inspire. So in progress are with the new customers from municipalities and also corporations outside of Hesse. On my last slide, I show you the future activities, how to expand the use of the ISS. To increase the benefits for the geodata providers and users is our aim. In focus to expand highly available geodata to optimize e-government activities in the field of environment, transport and statistics and more, even as input in mobile apps. Another aspect is the geodata integration in application theme portals, as we have done for the authorities. I'm not used to speak in this. As we have done this for the authorities in Hesse. For example, one link to the Landesplanung in Hesse. At all, the ISS, and it's important, is not a service limited on Hesse, and it's open for municipalities and for other geodata partnerships, also outside from Hesse. Because sharing IT processes, IT infrastructure and IT resources, not only IT resources, also personal resources, reduces single costs and the public budgets are relieved. The HZD is a non-profit organization and has the issue to minimize the IT costs for the public sector. So, one last sentence. The realization of the shown ISS benefits, in contrast to a single IT solution, is a first step. If you are more interested in this ISS, you are welcome to contact me in the coffee breaks today or tomorrow, or you send me an email, or Mr. Vogtländer said already, you can contact Mr. Vogtländer at the S3 booth. So I thank you very much for your attention.
Okay, thank you. Thank you, Petra. Thank you, Michael. Is there a need for a final question, or you want to discuss all that in the coffee break? That is now up to you. Is there a final question to this presentation? It's running over time, so I'm a bit strict here. Okay, I see you heading for coffee. Thank you again very much for your presentation. I think you're around for questions and discussions.
Okay.
And I wish you all a nice further conference.
Naja.
Did you already fill in this?
No, I don't fill it. I talked to Hugo and Karen. I send an email directly.
Okay.
No?
No problem. Thank you.
Ja, genau. Also, I mean,